First of all, good morning to everybody. Thank you for coming for my presentation. Today I'm going to tell you about the article I read, which is called Criteria for Saturated Magnetization Loop. So it's important for researchers to know about the characteristics, the magnetic characteristics of the materials. And one way to analyze these characteristics is by analyzing their hysteresis curves. So here we have what is supposed to be a hysteresis loop. It has this shape, something like a leaf. And for the characterization, what is important for us is analyze the coercivity field, represented on the graphic as the HC, and also the remanent magnetization, represented for the MR on the graphic. I forgot to say this. So hysteresis curves are usually a graphic where we have the magnetization versus the applied magnetic field, represented by the H. Okay, so when we have a hysteresis loop, we can define them as minor loops or major loops. In this image, the major loop is the black one, the biggest one, the larger one. And the minor loops are all the others, the colored ones and the smaller ones. So when we are reading about this subject, it's important for us to know when the curve is saturated or not. When we reach the saturation magnetization is when we apply the field, a high field to get the magnetization. So our material will be saturated, and that is important for us. But we have the saturation. The major loops are when we have the saturated curve. But when we get the minor loops, we don't have this saturation. So there's an issue, there's a problem, and when we have the minor loops, you can see the colored ones that they have a little shift related to the black curve. But we don't have this shift only for minor loops. There's another thing who also There's another thing which is also shifted when we see it on the graphic, and this thing is what we call exchange bias. Exchange bias is a relation that we have when we have a material composed by a ferromagnet and also an antiferromagnet. So you might have your graphic showing a minor loop or an exchange bias, but visually it might be the same thing because both of them represents the graphic a little shifted. Both images I put in there are for the exchange bias. You can see where the dotted lines cross each other is the center of the axis, and the hysteresis curve is shifted to the left, but it can also be shifted to the right. So we have shifted loops, but they might be an exchange bias, or that might be just a minor loop. They're the same thing. So the article shows this problem for us, and it will show us three methods to know if we have our curve saturated or not. I will talk about only one method, this one, which is called singular point detection, or just SPD. With this method, we analyze the successive derivatives of our curve or of our function. And yeah, okay. There we have two hysteresis loops, one in the left and one in the right. And just below we have the first derivative of a region of this graphic. And well, on the curve of the left, the first derivative shows us the descending curve and the ascending curve, and they overlap each other, okay? And when we do the second derivative, we also can see that the curves overlap each other. On the other graphic again, on the other graphic in the right, we can see that the ascending and the descending curves don't overlap each other. And what does it mean to us? When they overlap, this tells us that our curve is saturated. So it is a major loop. So the left curve is saturated one, and the right one is not, just because of the overlapping of the curves over there.